Hi guys, welcome. It's been a while. So what are we doing today? What I want to do is look at how do you protect your environment from lateral movement once a threat actor gains access to your environment and compromises an account. And specifically, I'm talking about ADDS, which is very difficult to secure. Lots of security holes. Modern cloud IDPs like Entra and Okta, for example, have native MFA. ADDS does not. It's not easy to ring fence accounts. You get some built-in mechanisms such as authentication policies and silos, which I did in the previous video, but these are complex, difficult to set up for large environments, and they're limited in the scope of what they can actually achieve. So what I like to be in my personal or my professional life is vendor agnostic. So if I go to a client and they've got a specific problem, I first want to listen to that problem, do analysis, assess what gaps they have, and then I look at what can I do to fill those gaps with whatever product or configuration is necessary. I don't want to go in with a preconceived idea and tell you what you need before I know what your issue is. But this video is going to be product specific, and I'll do a few more videos around lateral movement and how we can prevent them, and also how it's done, And the product that I'm going to use in this video is one that I've worked with quite a lot, called Silverfort, which you can see in the corner there. And it's a great product, and it allows you to really protect ADDS as you would Entra or a cloud IDP, and it extends that functionality to your local on-prem environment. And you can protect almost anything with that. You can protect RDP, you can protect command line interfaces, you can protect SMB shares or file shares, anything that uses authentication on ADDS through Kerberos or NTLM. So yeah, let's get into it. So firstly, I just want to show you where Silverfort fits in. So I've got a little graphic where the threat actor is thinking and preparing how is he going to get into the environment, him or her. And they are scanning the internet and looking for a way to get into the environment. And what we have is we've got stolen credentials that they can log in via a VPN, RDP or SSH. Or perhaps it's a phishing mail with a malicious link where they get malware, so they got a backdoor into your PC, or it could be credentials that they steal through a phishing link, or an internet-facing system and an app, and you can't see this, but it's attack IoT device, which doesn't actually happen that often. So yeah, that's how the threat actor wants to get into the environment. Once they succeed in one of these, then they get to the endpoint, so the compromised device. I've compromised it through malware, and I've got a backdoor, or through legitimate credentials. I've got a compromised account already. And then once I've got that, what I want to do is I want to move laterally within the environment. So I want to move from that workstation to a server, for example. I want to steal more credentials. I want to see if I can privilege escalate through the lateral movement paths until I get to domain admin and domain dominance. And once I've done that, then I can deploy my ransomware. I can exfiltrate data and do a double ransom, double extortion, and I'll disrupt the environment and cause a lot of damage for the company. Where Silverfort fits in is right here, disrupting that lateral movement and by protecting the identity, and that's what we really speak about. And when I speak about identity perimeter, I speak about, and I mean that you protect the identity. And if you protect the identity, the threat actor can't do much. You need to be able to authenticate to deploy ransomware within an environment. So that's really what I want to do, and that's a great extra level that I can protect. When we speak about defense in depth, it's sure I want to protect all of these initial access points. I want to protect the endpoint, but I want to make sure if something fails, so for example, if IT does a misconfiguration, that there's extra layers of protection. And if an account gets compromised, if a threat actor is active in my environment, then I want to ensure it's as difficult as possible for them to move around laterally. Okay, so how does Silverfort work? So the high-level architecture is you've got your user and service accounts or machine accounts, whatever they are. They request access to resources through your Active Directory. Services and resources also do that. And usually what will happen is they'll request access, and then through Kerberos or Intel M, that access will be granted if they've got the correct credentials, and that's where it ends. Silverfort sits behind the Active Directory, behind your DC, and if I authenticate with an identity, then it gets sent to Silverfort for a second opinion. So this is a VM basically. There are two VMs, a node and an admin console. It gets sent to Silverfort. Silverfort gives it a second opinion. It checks its policies. If it's in a policy and MFA is required, it'll send it to the MFA service, and you'll get a prompt for MFA. Once you approve that, the authentication will be released, and you'll happily be granted access to your resource. So that's the basic architecture. I won't go into this in too much detail, but I'll show you in practice how it works. So yeah, I have my Silverfort console, and what I've got here is live authentications. So all of these are live authentications, and if one gets verified via MFA, it'll move to the top. One gets blocked, it'll move to the bottom. Just a nice little view, and I can search resources up here as well if I want to. I can search, for example, my own name, and then I can find whatever resources I have accessed. Okay. Then how does this work? Well, it works through policies as well. That's how I set it up. So I've got some demo policies here, but really what happens is it looks at the policies from the top to the bottom. So it first looks at allow policies, then deny policies, then MFA, and then notify. So if I want to exclude somebody from a specific policy, I can add them to an allow policy. What to look at specifically now and a bit later at the deny policies is an MFA policy. So I've got my name and I've got a test account. This is syncing to AD. So it's pulling via LDAP, it's pulling all my accounts. And of course, there's a service account that you set up with the system in the beginning with delegated permissions to be able to read all your objects and all of that. So yeah, you can see I can add OUs, groups, users, whatever I like. And the user and group, the source is all devices, but I could, for example, just use my computer that I'm currently on and say, oh, this only applies to that computer. And then the destination is my demo device. But this can be whatever device I can find, or it can be a group or OU. So for example, if I want to put a specific OU with certain servers in the policy, I can do that and I only apply to those. Then once I click through to this machine, you'll see that it's got a bunch of different protocols. I'm actually going to remove RPC from it. And then I've got terminal services, which is RDP, HTTP, which is actually used for remote PowerShell and WinRM, and SIFs, which is SMB, basically. So it's your file shares. Any file shares on this machine. So those are the ones protected, and then I can choose more if I want to, of course, and it'll protect those specific services. Also, I can choose what do I want to protect, Kerberos and Intel M, just Kerberos. I'll protect both of them, or do I want to do LDAP? And the auth type, of course, and then the tokens. What tokens do I want to use? So the tokens I want to use is MS Authenticator and Silverfort Mobile. So this has been integrated with my MS Authenticator. And then I've got other policy restrictions. So do I want to require MFA every time, or do I want to do it every 60 minutes, for example? From the last successful MFA or the last successful authentication. according to the source or the risk level. It's got a risk engine as well, so I can determine risks for specific accounts. So if an account is a critical risk, for example, I can apply an MFA policy to it, and that will MFA the specific identity if it tries to authenticate with that critical level of risk. Retrospective validation, so this will basically just send you a mail and said, was it you that authenticated? And unpaired user action. So this is also important. So I can put that on block or whatever the default is. And then if an account is not paired to an MFA token, so whether that is on Microsoft Authenticator or on this built-in Silverfort MFA, which has also got an app, they'll be denied. Okay, so that's basically it. So generally, if you look at it, it's like a firewall for identities. You've got your source, you've got your destination, you've got your action applied, and that's how you can protect your environment. So how does this look in practice? Hello. So I got interrupted a bit there by work. So the second part of this video, so let's test Silverfort and have a look at what it can actually do practically. So what I've got is I've got a mirror of my phone, my Android phone over here on the screen, so that you can see the authentication requests as they come through. So firstly, let's test remote desktop. So right, it's asking me for my password, and there we go, and you should see, yep, there it pops up, and I want to approve that sign in. It's approved, and boom, I've got access. So as soon as I approved that sign in, I got access via RDP. So if a threat actor had to compromise my account specifically, they would struggle. I would get a MFA push, and I would deny it because it wasn't me. Right, so what else can we do? So let's try a remote PowerShell session. So really anything, you can protect CLI as well, because you do need to authenticate with this. So once again, let me try a PS session, and immediately I get a prompt, this time on the Silverfort app, because that's the one configured on the policy, which I'll show you in a bit. I want to say yes. I'll grant access. There we go. I had access to the machine. Let's exit. That Kerberos ticket is cached, so I can't deny that one anymore. So what else can we test? Firstly, let me show you those authentication requests, and let me go to my user account, and as you can see, move this away, you can see here's my my request for PS remote, for PowerShell remoting, and I approved the request. If I want to see what policy that was, I can just click on show policy. It'll take me through to the policy, and it's this one, right? What I can also see over here, if I go back to my username, is I can see my RDP request and approval. So that's terminal services, of course. So I've approved that, and it's granted me access. And there I am within the VM. So let me sign out of that again. And let me try that again. This time, I'm going to deny the request. Right, so there we go. I want to copy my very long password, and you'll see I've got my authentication request coming through again. So what I'm going to do this time is I'm going to say no. I do not want to grant access. And as you can see, I've got a little error. The day of a restriction is preventing me from logging in, basically. And what does this look like on the logs? Well, there we go. So MFA blocked. And it's saying I'm a user at high risk. And I can also click through to the policy, of course. But yeah, I've been denied. So from a threat actor's perspective as well, lateral movement wise, it's great. So let's take another example, Carly. So what I want to do is, already got the command set up. So impacket PS exec, which is a great offensive tool. The impacket library has a lot of scripts, and I'll be going through those as well in future videos. It's an awesome tool, and it's got a lot of different methods that you can use to attack machines. So I've got impacket PS exec here. So this specifically will upload a malicious file. It'll start or create a service, then start a service to run that file, and then connect back and create a shell for me. And it will create that shell with system privileges. So the highest privileges I can have on any specific system. So very powerful. Any EDR should block it. But I have seen cases where it doesn't. So what I really want to do is, before I even upload that malicious file on the authentication layer, I want to block it. So let's have a look. Try that. There we go. There's my signing. So I do not want to approve this because it's a threat actor that's got my account. I did not do this. So I can report it as well. For this example, dismiss it, and boom, the login request failed because the trust relationship with this workstation and the primary domain failed. So Kerberos said no, or possibly Intel M. Well, let's have a look. And there it is. Let me just check here. Yeah, there it is. So there's the terminal services. And it has been denied. Just want to see. I don't see that specific. Oh, I'm on the wrong account. That's why. Not very clever. So I use this test account of mine, and there we go. There you can see Intel M. All right. So I tried Kerberos, and then it defaulted to Intel M, and it's saying it's blocked and denied. It's got some nice risk indicators as well. It says I'm a user at high risk and I'm a user with the SPN. And if I go through to the policy, it'll show me exactly which policy is blocking it. And it's the all servers, all users policy. And yeah, easy as that. And I've blocked an account. So very powerful stuff and great at reducing lateral movement. So if somebody gets through all my other defenses and they are on my LAN, however that might happen, and they try to move within the network to gain a foothold, gain persistence, and also to deploy ransomware, exfiltrate data, execute whatever they want to do, it's going to be very difficult because they're going to have to prove that it is them with something that they have, in this case, a cell phone with MFA. So what I can also do is I can protect service accounts. So I've got a service account here, SVC accident 2, and I've allowed certain sources and certain destinations. So it's a virtual ring fence. Now I've actually, for demonstration purposes, allowed my account or my computer and my IP. So what I want to do is I'll use RDP as a nice visual example. So I want to RDP to this box. So let's have a look, and access allowed. Okay, I can't register this specific account to any one user's phone or MFA because it's a service account. Hence, it works on different. It works in a different way. You get machine-to-machine service accounts, etc., etc. But they're difficult to protect. No one user uses this. It's used for a service, and generally they're difficult to protect because I don't want to change the password, etc., etc. So now it works. So what I'll do is let me remove my allowed sources and destinations. Then I'm going to save that because I'm not going to MFA. Right, it's saving, it's synced all the policies. Now let's try that again. So this service account, and let's try and it's not working. And I've been denied. I can't RDP. Let's have a look what exactly is happening with this and why that is. As you can see here, I've got the logs for that specific service account. And if I look at these logs, let me zoom in a bit. If I look at these logs, I can see that firstly, I've got MFA unpaired allowed for that specific account. I can change that, but it's been allowed. Okay. And then after I change that source and destination on that service account and said, well, it's only allowed to authenticate from this source to this destination, and those that it just authenticated with are not allowed, I was denied. And there I can see the risk indicator. It's a suspected service account. Very nice. So even if I compromise this service account, even if it's a privileged service account, I won't be able to use it anywhere else except the service and the source and destination for where it was intended. All right. So amazing tool, and yeah, something that can definitely, in a hybrid environment, in an environment where you're still using a lot of Active Directory domain services, which a lot of companies are, and which a lot of companies will continue to do for the foreseeable future. It's great for lateral movement. It has more features, of course, but I don't have time to run through everything. Perhaps at a later stage, I'll do a deeper dive into the platform. But it can do other things as well. You can extend, for example, conditional access to your on-prem environment. So any conditional access policies you have configured on Intra, we can extend them and apply them on premises. So some very cool, powerful stuff. But yeah, I think that's it for this one. So join me next time, and then I think we'll continue with a little brute force series and have a look at Windows cheap ways to protect your Windows machines from brute force, and just play around a bit and have some fun. All right, I'll see you then.